This is the first in a series of videos on counting. Now in math, when we talk about counting, sometimes we use the term combinatorics, we basically are answering the question, how many ways can a certain thing happen? And the first problem we'd like to look at is, it's called officially the fundamental counting principle, but I like to think of it as the menu problem. And if you think about the menu problem, let's just look at an example. Let's say you go to a restaurant and you have 3 different salads to choose from, and you have 5 entrees, and you have 4 possible desserts. And let's say this is a restaurant that's near your house and you're asking the question, how many different meals could I order when I order 1 salad, 1 entree, and 1 dessert? And it turns out the answer is pretty easy. The answer is simply that you take 3 times 5 times 4. And that's 15 times 4, or 60. So there's 60 different ways that you can order this meal. The general idea of a fundamental counting principle is that if you have an event that you can, 2 different events, and event A can happen in different ways, and event B is it can happen in different ways, then the number of ways that you can have A and B occur would be simply M times N. And that's what we got here. Here we had 3 possible events: ordering a salad, ordering an entree, and ordering a dessert. And you multiply 3 times 5 times 4. You can actually visualize this by doing a tree diagram. So let's think about salads. If you think about salads, then you can order 3 different salads, right? Salad A, salad B, and salad C. And then after you order a salad, you can order an entree, and for each salad you have 5 different choices. 1, 2, 3, 4, 5. Right? So one possibility is you order the first salad and you can order any of 5 entrees. If you order salad B, you can have 5 different possibilities. And if you order salad C, you have 5 different possibilities. And then if you simply add all the different possibilities up, you get 3 times 5, or 15. And that's just 3 times 5. Now, if you order the first salad and the first entree, then you have how many different desserts to choose from? 4. So here you would have, if you wanted to, you could have, here's 4 different desserts. And if you draw that out, then you'd get a total number of outcomes, 3 times 5 times 4, or 60. And that's the idea between the fundamental counting principle. Sometimes it's also called the multiplication principle of counting. There's another problem that's somewhat similar, but it's a little bit different. And this is the case. Sometimes this is described as simple permutations, but I like to think about the problem of how many organizing people in a row or putting books on a shelf. So let's just look at an example. Let's say you had 5 people, and what you wanted to do is you wanted to line those 5 people up. Well, you have 5 people. The key is you have 5 spaces as well. 1, 2, 3, 4, 5. And this is space number 1. And the key insight here is that you have 5 people that could sit in seat number 1. Now, once someone's sitting there, however, in the second seat you have not 5 possibilities but 4 left. And then after you choose the first 2, then you have 3 possible people that can sit in the third seat. And it goes from there. So if you ask the question, how many different ways can I arrange 5 people in a row, the answer would be 5 times 4 times 3 times 2 times 1. I think I can do that in my head. That's 20, 60, 120 times total. Now, sometimes I like to call this also books on a shelf, because if you think about it, whether you're organizing people in a row or books on a shelf, it's exactly the same problem. So let's say you had 5 books and you're arranging them on a shelf. 1, 2, 3, 4, 5. So you have 5 books, but you have 5 places on the shelf. And the total number of ways you can organize the 5 books on a shelf, again, would be 5 times 4 times 3 times 2 times 1. So even though in one case there are people in a row and the other books on a shelf, mathematically they're exactly the same problem. And to the extent that this has a name, we call this simple permutation. So oftentimes people just don't actually name this, just kind of use your common sense to solve it. A problem that's somewhat similar is called the license plate problem. Now the reason the license plate problem, so let's think about the license plate problem. Let's say you have a license plate and it has 3 letters and then it has 4 digits. So for example, one possible license plate would be RXM2329. Right, you have 3 letters and then followed by 4 numbers. Well, a key question in the license plate problem is, can you repeat? And this is a good problem because it illustrates the importance of whether we can repeat numbers or not repeat numbers. And if we think about this for a second, if you can repeat, then the total number of license plate you could have would be 26 times 26 times 26. Those would be, in the first 3 places you could have a letter in each, times 10 times 10 times 10 times 10, because there are 10 digits. Now, there are digits 1 to 9, but don't forget your 0 as well. So this would be the total number of different license plates you could have if you can repeat. And one neat activity you can do is actually multiply this out to see how large that is. Let's go ahead and do that on a calculator. That's 26 times 26 times 26 times 10 times 10 times 10 times 10. And you get, let's see, 175 million approximately 176 million different combinations here, possibilities. Now let's look at the problem then if you can't repeat. If you can't repeat, then there are still 26 possibilities for the first letter, but now there's only 25 possibilities for the second and 24 for the third. Why does this go down? Because once you choose a letter for the first space, then you only have 25 different letters to choose from the next one. And then in this case, this would be 10 times 9 times 8 times 7. And though that's still going to be a large number, if we multiply that out, then you get 78, about 79 million. Anyway, that's counting part 1, and after you finish this video, then you can watch counting part 2.